Hello everyone. Welcome to the another lecture of Chemical Bonding class 11. Myself Suman Singh. So in the last class we have discussed about the valence bond theory. So in today's class we will discuss about valence shell electron pair repulsion theory and shape of molecules. Okay. So we all know that ionic compounds contains ions, right? And it is held by electrostatic force, right? And which is non-directional. Now, when we talk about the covalent compound are what? They are rigid and directional, right? So this will result in a definite arrangement of bonded atoms. Okay. So as a result, what will happen? The different molecule will have different shape. Okay. And by the shape of the molecules, we mean that the structure. We mean the structure. Okay. Or we can say that by the shape of the molecule means different three-dimensional arrangement of atoms or a group of atom. Okay. So when we have to define this geometry or shape, we can define like this: the arrangement of bonded atoms or a group of atoms in a molecule is called what? Shape, or the geometry of the molecules. Okay. So there are so many factors responsible for the determination of shape of the molecules. Okay. For example, we can take the electronegativity of the constituent atoms or the molecules, number of bonded and non-bonded non-bonded or non-bonded pair of electrons. Okay. And we can also take the nature of bonding present and the type of hybridization of the central atom of the molecules. So what is hybridization, we will talk in the next lecture. Okay. Now, however, we have seen that each molecules will have a definite shape, and because the atoms combine to form molecules, so as to acquire what state of minimum energy for stability. Okay. And there can be only one arrangement of the bonded atoms in molecules leading to the state of minimum energy, or we can say definite shape and geometry. Okay. So when we talk about the valence shell electron pair repulsion theory, the shape of the molecules of the covalent compound. Here, this theory will account the shape of the molecules of a covalent compound with a very simple theory which was suggested by Sidgwick and Powell in 1940. Okay, Sidgwick and Powell in 1940, which was later developed, or we can say that which was later expanded by Gillespie and Nyholm, okay, in 1957. So what does this theory talk about? So this theory, which is called valence shell electron pair repulsion theory, is primarily based on the fact that in polyatomic molecules, when we talk about this theory, is generally talking about the polyatomic molecules. Okay. Polyatomic molecules. So this theory is based on the fact that in a polyatomic molecules, the direction of the bonds around the central atoms depends on the total number of bonding and non-bonding electron pair in its valence shell. Okay. Now, next is this electron pair placed themselves as far apart as possible in space. To why they are doing like this electron pair place themselves far apart as possible in space, because to have a minimum force of repulsion between them. Okay. So when we talk about the minimum force of repulsion, this minimum force of repulsion corresponding to the state of what? Minimum energy and maximum stability of the molecules. Okay. So we will see what are the points which is written in valence shell electron pair repulsion theory. The first point is electron pair in a valence shell of the central atom of the molecules, whether bonding or lone pair, okay, are regarded as what? Occupying localized orbit. Okay. Or we can say that this orbit arrange themselves in such a way that as to minimize the mutual electronic repulsion. Okay. As you can see, it is also written here It is written in a very simple thing. The shape of the molecules depend upon the number and the nature of electron pair present in the valence shell of the central atom. Okay. Now next is what we can say when we talk about the magnitude of the different type of electronic repulsion. It will follow a order which is written here. As you can see, it will follow the order. Let me write here. It will follow the order like this. The first one will be lone pair, lone pair. Okay. After that, lone pair and bond pair. Okay. After that, bond pair and bond pair. Okay. This will follow this arrangement, or we can say this will follow this order. Okay. And now this repulsive force will alter the bond angle of the molecules or ions. Okay. Now next is what we can say, the electronic repulsion between the two pairs of electrons will be minimized, or we can say that the electronic repulsion between the two pairs of electrons will be minimum if they are as far apart as possible. Okay. Now on the basis of this, some of the arrangement you can see that we have seen that BeCl2 will have a linear structure. After that, BCl3 will have a triangular planar. Okay, sorry, it will have a triangular planar. After that, when we talk about the CH4 or H2O or NH3 molecules, CH2, CH4, H2O, or we can say that NH3, these all are these all molecules have tetrahedral arrangement. Okay. Or when we talk about the PF PF5 or CLF3 or SF4, they all have what? Trigonal bipyramidal structure. Okay. And again, when we talk about this SF6, or when we talk about IF5 or SiF2 minus 6, it will have what? Octahedral shape. Okay. So we will talk about the shape also one in detail. So now next is what? If the central atom, okay, listen carefully, if the central atoms is linked to a similar atoms, okay, and if it is surrounded by a bond pair of electron only, okay, so at that time what will happen, the repulsion between them will be similar. Okay. If the central atom is linked to a similar atoms, and if and is surrounded by a bond pair of electrons only, at that time the repulsion between them will be similar. Okay. Now as a result, what will happen, the shape of the molecule will be symmetrical, and the molecule is said to have a regular geometry. Okay. Now on the other hand, if the if the molecule in which the repulsive interactions between the electrons around the central atom are unequal, or have an irregular, or we can say that distorted geometry, or in fact the presence of a lone pair in addition to the bond pair in the molecule, which causes what? Distortion in the geometry of the molecules. Okay. So now for example, we can say that in the example of, if we are taking the example of this NH3 and H2O. Okay. So we will see that the bond angle are not 109 degree 28 minute, and for this it is not 107 and 7 degree, sorry. When we talk about this, when you will see that the bond angle are not 109 degree and 28 minute, but are 107 degree, and for water 104.5 degree. Okay, respectively. Why it is happening like this? Because of the presence of lone pair in NH3, one lone pair in NH3, okay, and two lone pair in H2O. So this was about the valence bond, valence shell electron pair repulsion theory. As you can see, some of the example is given here. or we can say that the geometry of the molecules is given here. So first one is two charge cloud. So this will happen when the two charge cloud, as in the carbon atom, or two double bond, and SCN, one single bond and one triple bond. Okay, the clouds are far apart, or we can say that in opposite direction. Thus we can say that CO2 and HCN are linear molecule with the bond angle 108, as you can see here in the example here. As you can see this one, right? Let me zoom it. As you can see here, for carbon carbon double bond here, so the shape is what, this shape is called linear shape. Okay, and the angle between them is what, 180, right? Now next is three charge cloud. So at that time this will arise when three charge clouds, as in carbon atom of the formaldehyde, okay, where two single bond and one double bond is there, okay, and the sulfur atom in SO2 here, where one single bond and one double bond and one lone pair is there. Okay, so the cloud are farther apart when they lie in a same plane at a point to a corner of an equilateral triangle with a bond angle 120 and 180. As you can see example here, it is given. For example of SO2, it is given here. So due to this lone pair and lone pair, there will be a repulsion at that time. The bond angle will be 120. Okay, now again after that four charge cloud, as you can see, it will occur on the central atom of CH4. As you can see here in CH4, four single bond is there, and when we talk about the NH3, three single bond is there and one lone pair is there. When we talk about the H2O, we have discussed about this, two single bond, okay, and one lone pair is there. At that time the cloud are further apart if they expand towards the corner in a regular tetrahedron with bond angle 109.5 degree, 5 degree. Okay, so as you can see the shape of CH4 is given. It is, this is called what, tetrahedral. Okay, here also as you can see the shape of H2O, here you can see the shape of, sorry, the shape of NH3, and here you can see the shape of H2O. Okay, now next is five cloud system. So it is also same, and six cloud system is also same, as you can see here. Okay, for five cloud system, as you can see in the example of PCl5 or SF4 or CIF3, at that time what will happen, they are oriented towards what, triangular bipyramidal. Okay, and the three clouds lies in the plane, in the same plane, three cloud will be in the same plane. Okay, and towards the corner of the equilateral triangle, and the fourth cloud point directly up, and the fifth is down. As you can see this one, you can see axial position and equatorial position. Okay, so this position is called what, as you can see the arrangement will be like this position is called axial position. Okay, and this position is called equatorial position. So these three will be in the same plane, and these two will be in the different plane. Okay, opposite to each other. So this type of structure is called what, trigonal bipyramidal structure. This, always remember that this one will be equatorial region and this one will be axial position. Okay, so we will talk about this in detail also after in hybridization. So I hope you have understood this, right? So this type of structure is called what, triangular bipyramidal structure. Okay, now when we talk about the six cloud system, as it is what, octahedron. So here you will notice that there are as you can see 1 2 3 and 4, both are in what, same plane. Okay, and two are in the opposite plane, and the distance between them is 190 degree, as you can see 90 degree. Okay, so this will be the structure, like as in the example of F6. Okay, as you can see the structure is like this. Okay, so this four, this one two three four, these are in the same plane, this is called equatorial position, and these two are in the axial position, as you can see. And then in the case of xenon fluoride, okay, here also you can see two lone pair is there here, and 1 2 3 4, these four are in the same plane. Okay, so I hope you have understood about the valence shell electron pair repulsion theory, right? So in the next class we will see about the hybridization. Okay, till that, thank you.